Well, thanks everyone for sticking around for the last presentation today. We're the automatic nail hole filler group. My name is Nathan Boone.
I'm Brooke Lindsay.
And I'm Katie Rupp.
If you're not familiar with the current process of filling nail holes after trim has been installed, it can be a super tedious and time-consuming project. This video just kind of demonstrates it a little bit. And right now, there's really no effective way of doing this. So our solution to that is a device that will fill these nail holes efficiently and effectively with the hopes of reducing labor and also saving workers lots of time on jobs. The long-term goal of our project is to integrate this design to create an attachment to electric nail guns that can automatically fill these nail holes either during the nails installation or immediately after the nails installation. Currently, we're in phase 1 of this project, which is basically focusing on the material delivery system because we found that this was the most important component, so we want to perfect that first. So in order to perfect that system, our main objective right now is creating a separate device that can minimize the amount of time required to fill these nail holes after installation. And then once we can perfect that, then we look to combine the whole process into one. Additionally, we want to develop a consumable cartridge similar to like printer and ink. So you purchase the device and then the cartridge contains the wood filler. And so once you fill a certain amount of holes and the filler runs out, you replace it with the new cartridge. And then within our objectives, some of our focuses are creating an inconspicuous finish, having a faster and more efficient method than the current method, and having a quick clean.
So this is our block diagram. As Brooke kind of went over earlier, when we were presented this project, we kind of thought we were going to jump right in and create the attachment and did that kind of all done in 1 year this year. That's not going to be the case. Like Brooke said, we're going to be kind of in phase 1 of this project, which is going to focus on our kind of lower left part of this block diagram. We really want to nail the wood filler delivery system, and we done a lot of material kind of selection and just different material testing with all different types of wood fillers. And so far we found that the mid-wax wood filler works the best. It's water-based particulate, so we can kind of play around with the consistency to kind of get that desired result that we want for our system. And kind of the consumable product is a little bit of kind of what we're working on, but not really this year. Kind of go over that a little bit. And then maybe later on, if this project reaches another group in the next year or so, maybe we can eventually get this thing to be universally mounted to all different kinds of nail guns that exist already. But that's kind of where our block diagram started, and we're now kind of just moving and focusing on that phase 1 of the system.
So currently on the market, there are no technologies to automatically fill the nail hole. The only method is, as the first video showed, either using your finger or a putty knife to kind of smear the filler in, and then coming back later with either a rag and wiping it off, or sanding that filler down, depending on the finish you need to achieve. The only thing that would be comparable to our end goal would be a pin nailer. All it does is it shoots a really small nail. So on darker trims, the nail hole doesn't show up as the nail hole is not as visible. So in that picture, the top right nail hole is the size of nail hole we are trying to fill, and the pin nail is all the way at the bottom there. One of the downsides to this technology, though, is there's no head on the nail actually, so you lose a lot.
So just to start with some of our design testing, our nail gun that we purchased to do some testing and to kind of initially design our project around, it has 2 different modes that you can shoot the nails on. The first is kind of the single shot mode, where you have to engage the safety on the end of the nail gun and then pull the trigger, and then that would send a single nail into the material that you're nailing. And then it also has a rapid fire mechanism on it, where in order to shoot the nail, all you have to do is hold the trigger down, and every time you engage that safety on the nail gun, it fires the nail into the material. When we kind of tested these two different methods, kind of the orange boxes up there are going to be that rapid fire. There's a lot of inconsistencies within the actual depth that the nail goes into the material. And that just kind of is based off a number of factors. On that rapid fire mode, there's a lot of bounce every time you shoot that nail. And then also there's different grain structures within a 2-inch piece of trim. You're going to hit harder grains. The nail's not going to go as far. You might hit a stud behind the wall into the piece of trim that you're nailing. There's just a lot of inconsistencies. It's really hard to fine tune and get an exact depth and repeatable depth every time you nail that nailer. Then in that red box is that single shot system on that nail gun. The standard deviations of depths of nails on the single shot was lower, so there are less inconsistencies there. And I think it's just more from you kind of are putting the same amount of force into that gun when you shoot it on that single shot method. But when you do that rapid fire method, you're kind of just bouncing along, and you're going to get some inconsistencies there. So because of that, kind of going into our design process now, we decided to oversize our hole to a volume of about 115 hundredths of a milliliter. So the volume of a nail hole is pretty small anyway, but we're going to oversize that, and then we are going to hopefully come up with a good smoothing operation to add on to our design.
The other test that we did this semester was to determine the force that we needed to push the material out of our cartridge. So to do this, we used 4 different size syringes. We used 1 milliliter, 3 milliliter, 5 milliliter, and 10 milliliter. And then we filled all of these up with our wood filler material and placed weights onto the plunger until the material moved. And then we recorded all these values and compared them to each other. And we found that the bigger the syringe size, the more force that was required to push that material. So we overall decided to use the 3 milliliter syringe because it can still fill a good amount of holes. It fills about 150 nail holes, but it still only requires a little over a pound of force to push that material out.
So this is our SolidWorks model for our design solution right now. As you can see over on the left side there, that's kind of what we hope our project looks like at the end of the year. It's got a nice, pretty standard, looks kind of like a power drill or anything else, your standard power tools. It's got a nice handle on it. It kind of houses all the main components that are inside. And then on the front of this, obviously, you're going to have to be able to replace that syringe, which is our replaceable cartridge for the time being. We're just going to actually get a bunch of those 3 milliliter syringes and fill them full of filler and throw it in there when we come to our testing phase of our project. But our system kind of runs on a linear actuator. Right here, you can see it's in position up top and then in the out position down there. But like Brooke said, that 3 milliliter syringe roughly fills 150 nail holes. So from this position to this position, we've got to take 150 steps to get there essentially. And through some Arduino code and all of our electronics, we should be able to achieve that with the linear actuator that we have chosen for our design. But then other than that, this tool, you would basically just kind of, maybe it's a construction crew that would buy this tool, but they would have someone going around nailing, and then you would take this tool, follow up behind them, find the nail hole, shoot some filler into the hole, and then still kind of going through some design solutions for our smoothing operation. We thought it would be a good thing if we can get this done, and then you have to take maybe a wet rag or something to just smooth that excess filler off. That's kind of what, that'd be a good goal for us to get to that point this year. So for right now, we really just wanted to kind of hammer down this, material delivery system. So that's kind of what we're rocking with for design right now.
So using our design testing we did earlier, we were able to determine the displacement we needed our linear actuator to move each time you want one nail hole's worth of wood filler, which is very small, less than half a millimeter. Then the other tests we did determined that we needed only a pound of force, and our overall stroke needed to be roughly 2 inches. So we found this actuator here, which has a 50 millimeter length option and can provide our force and roughly our accuracy we need. As the accuracy or the amount the actuator can, the small amount the actuator can move increases, the cost also significantly increases. So we're going to start off with this actuator because it's only $80, whereas other actuators that we know will work right away cost in the $400 to $500 range and have their own proprietary controller, which a lot of the time will be and not necessarily usable for a handheld tool. Then to control this linear actuator, we'll use a M12 Milwaukee battery because it's already in a good small form factor. That will supply power to a L298N motor driver, which will use its onboard voltage regulator to power our Arduino Nano. And then with a little bit of logic and a few inputs from the linear actuator, we can then use that motor driver to control our linear actuator.
Here's our Gantt chart that we have so far, just showing some of our milestones. So right now we're at the senior design conference, and then so after that we'll just be finishing up our design, finalizing our budget, and getting ready for our critical design review. And the goal of that is to walk out of there with kind of an okay on our design, our final design, so that when we get back second semester, we're ready to start constructing.
I guess going into our budget, when we were presenting the project, our sponsor gave us a budget of between $1,000 and $1,500. Right now we're sitting at about $685. So we're doing pretty good with that. The bulk of that is going to be in the nail gun and the battery that we purchased. Just because initially we thought we were going to incorporate that system into the nail gun all at once. So we decided to buy a nail gun. But it will be good to have anyway because we will be doing a lot of testing this spring with our prototype once we get everything built, and we can do a lot of testing with that. So we will still need that nail gun. All of our electronics that we'll need are relatively cheap. Bulk of that is going to be in the actuator itself, right around $100. But with a total of $685 and the budget of between $1,000 and $1,500, we're sitting pretty well so far. Any questions from anyone?
You said there wasn't anything on the market, but did you do a rough patent search to see if somebody had patented something similar?
I don't think we did a patent search. We Googled for hours. It seemed like the closest thing we could find was basically an electric cop gun. But for the nail hole process, we really haven't found much out there.
It's not that hard to do an online patent search. Just go to the U.S. Patent Office. Then you can put in hole filler. It's a little complicated, but I wouldn't be surprised if somebody at least has said, here's something, right? I don't know. You should check.
Do you think you'd have concerns with any smear of the putty whenever have insert that millimeter that the linear actuator moves, like they have with smearing with the finger? You know, they have a little bit of residue left over. Do you think you'd have any residue left over?
That's probably gonna come down to how we figure out a way to do our smoothing operation once we get there. Right now, with the way people do it, they either use a putty knife, just smash that material into a hole and then just kind of wipe away the excess either with their finger or with the scraper. Like I said, if that's what it is to do the smoothing of it, I think if we can develop our system to actually apply very fine and repeatable amount of filler, I think that's going to be a huge step in the right direction for where this project wants to go. If we have to take a wet rag after we're done and smooth it out, I think we're still going to be okay. Maybe that smoothing operation is somewhere down the line. We get that designed and have a good solution to it someday, maybe. But for right now, I don't think we're too worried about that syringe. Just the way we're going to run our actuator, it's going to run on like 2 steps forward, 1 step back to kind of relieve that pressure. So we're hoping to eliminate any of that drip or just that excess oozing of the material out of that syringe. So hopefully with some creative code writing, we can kind of make it pretty clean. So.
So every time when you inject material, it will inject same volume every time.
That's the goal.
So will you have something to adjust the volume, like if you want the less amount or maybe higher amount?
That would probably be something we could code into our Arduino code. Maybe it's 3 different buttons. You can have a less, a medium, and a more fill option. I don't think it would take very much work for that to happen. So maybe that's something we need to consider for our design. But yeah, that is a good idea. Thank you.
You have or this is maybe next semester testing, but how much faster this might be compared to traditional methods estimating?
We plan on doing that second semester to kind of have a little bit of both and actually do testing and
What about different types of manufacturers, putties and different viscosities and stuff? Will this be designed for primarily one type of putty?
Probably just one type. Having that material that's water-based, being able to kind of play with the consistency of it is nice right now, because you can actually get different results based on kind of the viscosity or the thickness of it. When we did some of our material testing, the thicker diameter syringes, you could actually push that fluid of the particulate past the solid. I think it's just sawdust basically mixed in there. You can actually push the fluid past all of that solid, and you're basically just left with a chunk of dry wood in the end of it, and it takes a lot of pressure to keep pushing it out. So the more the thinner we got the wood filler, the easier it was to kind of get repeatable results through our testing. And the thinner it is, the less force required to push that filler out of that syringe. So it is nice that we can play around kind of with our testing. We know that if our actuators get stuck and it's not pushing enough filler out, we can kind of just dump some water in the tub of filler, mix it up a little bit, refill it until we kind of get that consistency down. That is also going to be another thing with the consumable product. Right now, we aren't really doing anything with having a cartridge that's ready. That's probably why that syringe is in our design right now. But yeah, eventually, if there was a way to create a new material to just shove into those replaceable cartridges, that's the overall goal. So.
Okay, any other questions for this group? All right, it looks like that's it. So good.